Section 12 of the National Geographic Magazine, Volume 5. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. The Geologist at Blue Mountain, Maryland, by Charles D. Walcott. Most of the summer visitors at Blue Mountain, Maryland, give little thought to the origin of the mountain, nor how it came to be a ridge rising so boldly on the west from the Cumberland Valley, and on the east overlooking the mountain valley to the foot of the Catoctin Ridge, which rises above the plain stretching thence southeastward to Washington. During the summer of 1892 the writer discovered that the rocks forming the crest of the Blue Ridge belong among the oldest formations deposited in the Appalachian Trough, since they carry types of life occurring in the most ancient fossiliferous rocks on the North American continent that are distinguished by a recognizable fauna. The geologic structure also shows that these rocks rest upon the ancient seabed of the Appalachian Trough, and that they are of the same relative geologic age as the Cambrian rocks that occupy an equivalent stratigraphic position in Vermont, New Jersey, New York, Virginia, and Tennessee. The recent work of Dr. G. H. Williams demonstrates that, with one partial exception, the older crystalline rocks underlying the Cambrian strata have hitherto been misinterpreted and misunderstood by the geologists who have studied them. Instead of being sedimentary formations originally deposited in the seabed, they are volcanic rocks and almost identical with the lavas found in Nevada, Wyoming, and in many portions of the Rocky Mountain region. This discovery proves that the laboratory of nature produced a certain type of volcanic rock almost at the beginning of the evolution of the North American continent, and again produced the same type many millions of years afterward on the western side of the continent. The broad mountain crossing the Pennsylvania-Maryland line includes eastern and western border ridges and an intervening valley. On the western or Blue Ridge side, it is built up of sedimentary rocks originally deposited in the sea on the bottom, and it may be the side of the Appalachian Trough. In the intervening valley it consists to a considerable extent of eruptive rocks, which poured out as flows the ancient land surface prior to the existence of the Appalachian Trough and before the deposition of the stratified rocks which so largely form the North American continent within the limits of the United States. The elevated eastern side forms the Catoctin Ridge, which is capped by a compressed fold of the old shales and quartzites. Both ridges continue south of the Maryland line toward Harper's Ferry and far into Virginia as compressed synclinal folds of the Cambrian rocks, resting on the rocks of the ancient Appalachian Trough, the older rocks and the more recent rocks having been involved in the same series of folding. In addition to this folding, numerous thrusts of one mass of rocks upon another are to be found all along the Blue Ridge, especially north of the Pennsylvania-Maryland line, in the northern extension of Blue Mountain, or the South Mountain of Pennsylvania. In some instances the ancient eruptive rocks have been thrust westward, so as to rest upon and above the more recent sandstones and shales which were originally deposited upon them in the bottom and along the shore of the Appalachian Trough. Often the pressure has cleaved the massive lavas and formed slates and shales that appear like those deposited in quiet waters. The result of this has been to complicate the geologic structure and topography of South Mountain and the Blue Ridge, and to make the region one of great interest to both professional and amateur geologists. Erosion has aided their study by cutting away thousands of feet of strata from above the present mountain area and adjacent valleys, and thus laying bare a portion of the ancient shoreline of the Atlantic coast area of Cambrian time and of the foundation upon which much of the present continent is built. The history of the Blue Ridge and its rocks, as now interpreted, is essentially as follows. It began long after the first known primitive rocks of the earth were raised into plateaus and ridges to form the platforms of the present continents. At the close of the periods in which the earlier crystalline rocks of the continent were formed, and also the great masses of bedded rocks beneath those containing the Cambrian or oldest known fauna, that portion of the North American continent then above the sea is thought to have consisted of (1) a large part of what is now the British possessions; (2) a long, broad mountain area (Atlantic) extended southwestward from Newfoundland to the present site of the Gulf of Mexico, and it may be the West Indian Archipelago; (3) and one or more areas (Pacific) on the western side of the continental plateau, on the line of the present Rocky Mountain and Sierra Nevada ranges. The eastern or Atlantic area and the bed of the interior sea toward the west, in what may be called the Appalachian Trough, were then formed of various kind of rock, including granite, schists of various kinds, crystalline and unaltered sedimentary rocks, and in some localities of great masses of volcanic material that had been poured out over the surface in very much the same manner as were the relatively recent lavas found in the vicinity of the Yellowstone National Park and in various parts of the Rocky Mountain region. The waves of the interior sea wore away from the western shore of the Atlantic land area various rock materials and deposited them along with that brought in by the brooks and rivers as layers of sand and gravel on the sea bed all the way from the present site of the St. Lawrence River to Alabama. In these deposits, fragments of the volcanic rocks, schists, etc., were mingled and spread out in sheets. At times the supply of material was very fine and formed thin layers of mud that afterward consolidated into shales and slates. After a deposition of several thousand feet of this character of materials, the water deepened, probably by the subsidence of the bed of the sea, and calcareous muds were deposited during a great interval of time until in places they reached the thickness of several thousand feet. These now form the limestones found in the Cumberland and Shenandoah valleys, and their extensions northward to Canada and southward to Alabama. All along this ancient coastline, from Labrador to Alabama, various forms of marine life existed, and their hard parts, such as shells of crustaceans, allied to the living king crab, and other organisms, were buried in the mud and sand. The deposition of sediments in the sea, immediately west of the Atlantic area, continued until from 12,000 to 40,000 feet in thickness were piled over the ancient sea bottom, layer upon layer, sometimes of one kind of sediment and sometimes of another. These are now found as layers of sandstone, limestone, coal, shale, slate, and various combinations of sandstone, shale, etc. With the close of the first great age (Paleozoic) in sedimentation in the Appalachian Trough, the earth's forces again became active, and sufficient pressure was exerted from the Atlantic coast side of the continent to raise this great mass of sediments above the sea and to fold it in ridges and hollows, very much as layers of paper or cloth would fold from pressure applied to the edges of the layers if they were partially confined above and below. This was varied, however, in the great rock masses by the frequent shearing on the line of the folds and the thrusting of masses of rock one over the other as cards shift over each other under pressure. One of these folds, with minor folds within it, has by subsequent agencies been carved into the Blue Ridge. The epoch of folding was several millions of years ago, so long since that sufficient time has elapsed for thousands of feet of sediments to be deposited in the interior lakes and seas of the North American continent, and for animal life to develop from the then highest types of fish and reptile to the higher mammals, at the head of which man stands today. During the thousands of centuries since the first great Appalachian uplift, the rain, frost, and snow have been at work sculpturing the old land surface and slowly working out the mountains, valleys, and plains. It is not improbable that the process of mountain uplift and that of wearing away the mountains to a relatively level area (base level of erosion) may have taken place several times, the intervals of rest between the wearing away of the highland and mountains and the succeeding epoch of uplift being of long duration, so long, in fact, that centuries might pass without effecting a marked change in the relations of the land and sea. It was not far back, geologically speaking, that the Blue Ridge was a part of, and not distinct from, a great plain that was broken by low hills and valleys and drained by streams flowing into a river that occupied relatively the same position that the Potomac does now. The continent was then at a lower level in relation to the sea, and it was not until it became elevated that the Potomac began to cut down into its bed in the old plain and carry out to the ocean the material which filled the areas now represented by the Cumberland and Shenandoah valleys. As this process continued and the river lowered its channel, the Blue Ridge began to take shape as a distinct feature in the landscape. Slowly but surely the softer beds were broken up, dissolved, and carried away, and the harder beds of rock began to project above the ancient plateau. It was only the question of which beds of rock could the longer resist the forces of rain and frost to determine the location of mountains and valleys. We have thus hastily sketched the evolution of a portion of the continent and the evolution of one of its topographic features as shown by the Blue Ridge. This evolution has gone on everywhere. Every ridge, however small, every valley, whether shallow or deep, narrow or broad, every stream channel all over the surface of the continent has its history back in the past, and it is by the studies of the geologists that we learn something of that history. It is now nearly 40 years since William B. and H. D. Rogers discovered many elements of the structure of the Appalachian Mountains, but it was not until within the last few years that the means of correlating and thus interpreting more accurately the structure of the various mountains formed by the lower and oldest series of the sedimentary rocks have been obtained. During the deposition of the 40,000 feet of sediments in the Appalachian Trough, many millions of invertebrate animals lived and died along the shore and on the seabed. Those that lived in the earlier epochs became extinct and new forms succeeded them, and these in turn were succeeded many times during the vast interval between the first deposit and the closing one before the epoch of the last Appalachian uplift and folding. The remains of the various groups of life now afford the data by which the geologist correlates the various disturbed and often separated masses and determines what were their original relations to each other. There are hundreds of local details yet to be studied and interpreted, and the work will be done by those who love to study the record of creation in the fragmentary book of nature, where all is written that we know of the past before barbaric man began his imperfect record by myth and legend. End of Section 12. Recording by Karen.